We'll fire off those for a little bit, and then we'll do this homework quiz and probably be done for the day. Sound good? All right. Blake, start with you.
Okay, so how do you do number 44?
Carefully? Ha ha ha! No, I'm just joking.
I tried doing it carefully. Didn't work.
All right. It says Matt hits a baseball when it's 3 feet above the ground with initial velocity 115 feet per second. Leaves the bat at a 41-degree angle with the horizontal, heads towards 20-foot fence, 380 feet away from home plate. Write the parametric equation to model the ball. Okay. So we have x of t should be initial velocity times cosine theta times t. Y of t is negative 16t squared plus initial velocity sine theta t plus the initial height. That's part A. You get that?
Where'd you get negative 16?
It's part of the formula. Okay. They're always negative 16t squared. That's gravity. Okay. Part B, if no fence or other obstacles were present, find the distance the ball would travel when it first hits ground. So from a picture standpoint, here's the ball's initial height. Whoop. And we're looking for this distance, right? That's an x coordinate. What's the y coordinate of the ball when it's at 0? So I can use that 0 to plug in for y, solve that t, and then you plug that in for x of t to get the x coordinate there, right? We're looking for the x coordinate here. So I want to find the t at that spot when the y is 0. And then I can use that to find the x once I have my t. So to solve this, it's a quadratic equation. I'm going to use the quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2 times a. Calculator time now. I like to do alpha y equals to get the fraction bar because I think it makes it a little bit easier than having to deal with all the parentheses. So 115 sine 41 plus square root. And then around that 115 sine 41 squared, I need to put a parenthesis around all that. Oops. There, squared minus 4 times a times c all over 2 times a. One thing I'm going to check real quick before I press enter here. My calculator mode needs to make sure I'm in degrees. Okay. Press enter. So one answer is negative 0.39 seconds. Is that the answer I need? Nope. Clearly that shouldn't be a negative time when that's happening. So I'll just change the plus to a subtraction symbol. Press enter. I get 475-ish. So I'm going to do x of 475. So that's 115 cosine 41 times 475. So the ball goes 412.7 feet. Happy with that, Blake?
Static.
Okay, and then part C says, will the ball clear the fence? If so, by how many feet? If not, will the ball be catchable, i.e. is it less than 10 feet? Because that's probably about as high as a reasonably athletic baseball person could jump. So here's what's going on. The ball's coming here. I'm interested in what's happening when he gets to the fence. I know that this is 385, comma something. I don't know what the y coordinate is. I want to figure out that y coordinate so I can compare it to the height of the fence, which I think was 20 feet. Yeah. So I'm going to do the same thing, except this is an x distance. So I'm going to be putting that in for x of t and then solving. And the nice thing about that is that that's just a linear equation. So solving, it's a piece of cake. So 385, oops, I'm going to use the fraction command again, so I don't have to use the parenthesis. 385 divided by 115 cosine 41. So 4.44 seconds or thereabouts. So then I'll just do y of 4.44. So I have negative 16 times answer squared plus 115 sine 41 times the answer plus 3, right? Is it 3? Yeah, it's 3. So I get 22.8 feet or thereabouts. And since that's greater than 20 feet, that's a home run. Who was this? There's this Matt that did this. Yeah, Matt is a beast, huh? They'll probably intentionally walk him next time he comes up. Yeah. Blake, you have? Okay. Calculator problems?
Yeah.
So you'll chalk up most of it.
Cosine for the sine problem.
Oh, that would do it.
Screwed up everything.
It would do it. That's a Mr. Kulik mistake.
That one was an infuriating mistake, man.
Who's next? Happy to do a couple more. Enzo. I kept trying to turn that into Lorenzo, and I'm like, that's Lorenz and Enzo, and they just combined together and into the wrong name. 37, you said? 47. All right, let me get my numbers here to look at. All right, it says you are standing exactly 15 feet from the front of an 18-inch diameter circular target on the ground. Oh, you throw a lawn dart in the direction of the circle and release it 5 feet above the ground with an initial velocity of 30 feet and an angle of 70 degrees. Will your dart hit the target? Okay. So let's just sketch a little picture here. So this is you. And then 15 feet away is a 18-inch diameter circular target. So 18 inches is like 1.5 feet. I'm just going to do that conversion right now. So this right here would be like 0.75 on each side. So really this is going to be like 14.25 to the target. You guys agree with that? That's the way I'm reading that. Oh, from the front of. Shoopers, creepers, Mr. Kulik. Read the question, you dumbo. This is Mr. Kulik's making life hard. There we go. Everybody's cool with this? All right, let's set up our function here. X of t is going to be initial velocity cosine theta times t. Y of t is going to be negative 16t squared, always that, plus the initial velocity sine theta t plus initial height, which was 5 feet. And whoop, we're trying to figure out when that dart hits the ground, how far is it going to be away? And if it's between 15 and 16.5, we've hit inside the circle. If not, it's either going to be short or further. You know what I mean? So I'm just going to put 0 in for y. Solve that guy and then take that answer and plug it in for x and see what we get. Enzo. Oh, 70. Yeah, sure. I don't know where I got 71 from. Probably reading too fast, Mr. Kulik. Like a jerk. You're not the Micro Machines man. That's a reference probably nobody under 40 gets. So good joke, Mr. Kulik. Know your audience. Well, sometimes you just like talking and you make a joke and you're like, no one's going to get that joke. Do you guys know what hey, do you guys know what Micro Machines are? So they were toys in like the 80s and 90s. They were little tiny like cars and planes and stuff.
Oh, that's sick.
And the spokesman just talked really fast, like the fastest talking person you've ever heard. No, they were smaller than that. They're like this big. Like the car would be like that big, like that long. Just like that high off the ground. They're just little tiny toys. All right. Let's zip it a little bit here as we're nearing the end here. So we're able to find, using the quadratic formula, that takes 1.92 seconds in the air for that dart to land. So then we're just going to do 30 times cosine of 70 times that answer. And we land 19.74 feet away. And since that's greater than the end, which would be at like 16.5, you missed the target. Yeah, Hercules that. Way to go. I don't know what I would have said if it was exactly, right? If it was exactly 16.5. I don't know if does close count in horseshoes or hand grenades, but what about lawn darts?
You say bullseye.
Well, bullseye would be like 15.75, like right in the middle of the circle. Anyways, Enzo, feel good?
Yeah.
Cool. Luke, you had your hand up at one point.
That was my question.
The same one?
47, yeah.
Ah, righteous. 2 for the price of 1. Katie. 42 part C? Yeah, man. So in 42, in part A, you wrote the following equation, and I'm going to use that to do part C. So this is our equation for our motion. This is a one-dimensional motion problem because you're just talking about something being thrown straight up and down. So if I graph this as like a y of t plot, this is going to look like this. So that vertex is going to give me the maximum height and the time it takes to get to the maximum height. So all I need is negative b over 2a. And then I'm just going to plug that value in. And that'll give me my time and then height. And you're good with just doing that? Yeah. You could use your calculator to do it too if you wanted to, like type it in, use the maximum command on your calculator. Not wrong to do that either, but I mean, I don't need it, Alyssa, I see your hand. Thinking about it?
Yeah, I just have a few questions. So for one, is the equations for these story problems going to be on the homework quiz and the test?
Well, they're not on the homework quiz, but you don't need it.
Okay.
Because I wrote the equation for you.
Okay. And then
Happy Irish Week.
Yeah, thank you so much.
And then we'll worry about the test when it gets a little bit closer to the test. Is that fair?
Yeah, that's perfect.
Okay.
And then can you just do 39?
39. Yep. All right, 39. Sure. If you just keep asking questions, we're just eventually going to run out of homework quiz time, and then you're going to have to get zeros for it. So this was for a unit circle, right? So the radius was 1, and the center was at 0, 0. If I want the radius now to be 6, that maximum value for cosine is currently 1, right?
Yep.
If I multiply all the values of cosine, it'll stretch that maximum value out to be 6 now. And if I do the same thing for sine, it'll stretch it out vertically, so it's going to now have a radius of 6. And if I want the center, which is at 0, 0, to now be at 0 or negative 1, 2, well, I need to move all the coordinates to the left 1 unit. So I just subtract 1 from all the x coordinates. I need to shift it up 2 units. So I'll just add 2 to all the y coordinates. And then the interval that I'm going to use here, anything that's at least the length of 2 pi is fine, but the easiest one to use is just 0 to 2 pi. So you just cover all the possible values of sine and cosine. But if you did like 15 to 37, that's okay. That's at least 2 pi long. It's a weird interval to choose, but okay. I'm not going to complain about it. Does that feel okay?
Yeah, and then why did we do like 38? Why did we do like the equation for like a circle?
So you would have confirmed, well, I don't know. You shouldn't have. It said just find the parameterization for 37 and 38. Yeah. I mean, if you did like 25 through 28, you would have ended up with the equation for a circle. But on 37 through 40, you go in the opposite direction. You're starting with the circle and trying to get a parameterization from it rather than a Cartesian. Yeah, no problem. So just starting with the unit circle and then altering. Yeah, is fine. All right, let's do the dang thing, huh?